Welcome back, math fans. Today we are going to take a look at some of the properties or the rules that make the real numbers behave the way they do. It governs the behavior or the operations, if you will, of the way we work with real numbers. Each one of these, if you look down your list, has two pieces. So the first one is the associative property. And you'll notice it has addition and multiplication. When you look at the second one, you have addition and multiplication. When you look at the third one, the distributive property, it applies to addition and subtraction. So when you're working with these, one size doesn't necessarily fit all. But let's start with the associative property. Green will work. So let's say we have three numbers. We have 3 plus 4 plus 5. And I'm going to group the 3 and the 4. Now, we haven't necessarily talked about order of operations yet. But when we get there, we'll talk about doing parentheses first. Well, here's what the associative property says. This is kind of like the grouping property. It says I can do 3 plus 4 and then add 5, or I can get exactly the same result by grouping the 4 and the 5. Either way, both sides of that equation gives me 12. If I want to say this mathematically, I would say for all real numbers, we'll call them A, B, and C because I'm not feeling super creative. A plus B plus C is equal to A plus B plus C. The associative property of multiplication is very, very, very similar. The only thing we're going to change is the operation. So if I use the same numbers, I could do 3 times 4, then multiply by 5. Let's say that the 3 and the 4 aren't friends anymore. 4 wants to go be friends with 5. So I can multiply the 4 and the 5 and then the 3, and it all comes out the same. Either one of those situations is going to give me 60. So we regroup. If I were going to use A, B, and C again, I can say A times B times C is equal to A times B times C. And I guess I can put my little dots in there so I'm consistent. So now let's go take a look at the commutative property. In this word commutative, I hear the word commute. And I know that if I'm commuting to work, it means I leave my house in the morning and I drive to work. Then, in the afternoon, I leave work. I'm going to cheat. And then I go home. So I'm going to hop in my car. And I am going to cover exactly the same distance. We're not stopping at Target. We're not stopping at H-E-B. We sure as heck are not stopping at Walmart. So I traveled the same distance. But I traveled in different directions. I traveled opposite directions. Well, Ms. Graham, what the heck does this have to do with math? This is a math class, not a driving class. Bear with me. When we talk about the commutative property, this means our numbers, so I'm going to do addition. I'm going to stick with 3 and 4. If 3 plus 4 is 7, the commutative property says I can use the same numbers in the opposite direction, the opposite order, and get the same result. It says I can go from home to work and from work back to home and cover the same space. If I want to put this in word or in math speak, we would have to say for all real numbers, we'll use P, Q, and R. I don't need an, well, yeah, I don't need an R. P plus Q is equal to Q plus P every single time. The multiplication one is very, very similar, just like with the associative property. We could multiply 3 times 4, and that would be equal to 4 times 3. We can reverse the order, but get the same product. So, for all real numbers, P and Q, P times Q is the same as if we reverse the order. Now, the distributive property is the one that you are probably the most familiar with from your algebra classes. The associative and the commutative property happen all the time. We just really don't think about it when we do it. The distributive property is more of a conscious effort. So I'm going to switch colors and we'll talk about the distributive property. When I hear distributive. I immediately think about things being distributed or given out. Given to everyone. So I want to give you a little bit of a mental image here. Something that most of you have some experience with. So, this is you. And you are taking maybe your cousins, maybe your little brother and sister, two kids to go get ice cream. And you think in all of your wisdom that you can give an ice cream cone to one kid but not the other. Not a great idea, folks. You have to give ice cream to both children if you value your life. Same idea with the distributive property in mathematics. Typically, you will see, we'll do it with numbers first, then we'll do it with letters because that's the one you're more likely to see. You might have 3 times 4 plus 5. And yes, I realize you guys could add 4 and 5 and get 9 and multiply by 3. No big deal. But here's what's happening. I am going to change these so the color stands out a little more. What the heck, we'll make them gray. I am going to multiply the 3 by the 4. Maybe. I'm trying to figure out the controls on the iPad update. Well, that's super fun. I'll pick a color that's already there. So I'm going to do 3 times 4. That was really huge. We'll try that again. That's better. Plus, and because I value my life, I'm going to give the 3 to the 5 also. You'll end up with exactly the same result as you did originally, but it happens in a little bit different way. In math, in this algebraic world that we are slowly venturing closer to, third time's a charm, right? It'll look a little different. You might see 3 times x plus 5. And it looks a little more intimidating, but treat it exactly the same way you would 2 little kids that you're giving ice cream to. 3 gets multiplied by the x. And then 3 gets multiplied by the 5. That's what the distributive property looks like. So we'll put it into words. For all real numbers, A, B, and Y. You thought I was going to say C, didn't you? A times B plus Y is the same as A times B. So we give the ice cream to the first kid. Then we give the ice cream to the second kid. Subtraction is almost exactly the same. The only difference is the symbol. So if we do 3 times 4 minus 5, this is exactly the same as 3 times 4. So we give it to the first kid. Minus, because of that minus, 3 times 5. If we were to, let me go make my notation the same. If we were to use an algebraic expression, exactly the same idea. 3 times the first thing, 3 times the second thing. To write the final answer, we would go ahead and multiply the 3 and the 5. So we would end up with 3x minus 15. Down on the numerical expression, this would be 12 minus 15, and it would be negative 3. But just to demonstrate the property, that's where we would end up. I'm going to cheat a little bit here. We'll say for all real numbers, A, B, and Y, and we're going to change that addition to subtraction. We'll look at some examples because it is all well and good to read the words and look at the pictures. It's a whole nother thing to apply them sometimes. Here we're not concerned about working the problems. We just want to identify the property that got used. What I see in the first one is that I switched order. The 3 was in the front, and now the 3 is in the back. So I need a property that says I get exactly the same thing on both sides, but I reverse the order. To me, reversing the order is the commutative property. That doesn't say property. There we go. So we switched the order. So let's see what happens in number 2. Number 2 has a bit of a typo in it. Number 2 needs those subtractions changed to addition. Then, once we have that taken care of, I have a 5 in the front and then a 5 in the back. So it looks like they switched order again. This time, because we're adding, this would be commutative property of addition, and I'm going to put multiplication on that first one. 3 right, let's take a look at what changes. On the left, we have the 4 and the 1 in parentheses. On the right, we have the 11 and the 4 in parentheses. So it looks like maybe 4 and 1 were friends in their same little group. And then maybe they had a fight and all of a sudden 4 has reassociated itself with 11. So it looks like we regrouped. That regrouping property was the associative property. And we are adding, so that will be of addition. Now this one looks a little different. I'm going to see if maybe I can rewrite that right side. I know 18 is 6 times 3, and I know 36 is 6 times 6. Then if I look at it a little bit closer, I see that 3 and that 6 inside the parentheses. And I see this guy out here. Well, that looks like what we very recently talked about in the distributive property. And they're both multiplication. I'm just going to say over addition. 5 looks very similar. No, it doesn't. Just checking to make sure you're paying attention. It looks like we have the 3 and the 5 together over here. On the right side, we have the 4 and the 3. They have regrouped. So this is the associative property. And we're multiplying. Now this one looks familiar. It looks like I have a 3 times x. Well, I could get that by multiplying the x times the 3. And this is an 8 times x. I could get that by multiplying the x times the 8. Well, I gave the x to everybody. So that is the distributive property. And everything was adding. So it's the distributive property of multiplication over addition. Now I was trying to see if you were paying attention on this next one. The big difference between, 6 and 7 is the sign. So this time, instead of being the distributive property of multiplication over division, or over addition, we will have the distributive property of multiplication over subtraction. 8 is the last one. It looks like we have just switched order. Switching the order is the commutative property. And we are multiplying. So this is the commutative property of multiplication. That brings us to the end of this leg of our journey for O300. Hope to see you in the next video.